Hello students, today we're going to be looking at the other type of reasoning. It's called deductive reasoning, and we're going to get an introduction on two-column proofs. Please don't forget to take notes as you go and complete the survey at the end. So we have two different types of laws that we deal with when we're doing deductive reasoning, and we use a lot of this type of reasoning when it comes to writing proofs. Our first one is called the law of detachment. And what this states is that if the hypothesis of a true conditional is true, then conclusion is true. So what we'll end up with is a statement such as P implies Q, or if P then Q is true. And then I state something along the lines of P. Now it's going to be similar to P. It's not going to be the exact same thing as that. And I'll show you an example as a middle. That's going to be in a moment. It's going to be very similar. So I'll give an if-then statement, and then I'll say another hypothesis, and then you can conclude that the specific Q is true. So let's look at an example of that. Okay, let's look at the first one there. If a student gets an A on a final exam, then the student will pass the course. So that's my original if-then statement. Then I'm going to go on to make another statement. Felicia got an A on her history final exam. So that's what I mean is that we get another hypothesis, but not another conclusion. You're going to be able to come up with this conclusion based upon the original if-then statement. So in this one, she got an A on her history final exam. So then you can say Felicia will pass her history course. So looking at a little bit more math-like, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. So now I'm getting more specific. So in general, I know that the ray, if that happens, is an angle bisector. So now I'm getting specific. I'm saying that ray RS is dividing angle ARB so that we have ourselves two congruent angles. So now what you can say about that ray is that it is an angle bisector. So that's the first of our two laws. So again, that's the law of detachment. Our second one is the law of syllogism. The law of syllogism allows us to take a conclusion from two conditional statements when the conclusion of one statement is hypothesis of another statement. Okay, so what I'm going to give you is a first if-then statement. So if P then Q is true, then I'm going to give you a second statement. And that's going to now say if Q then R is true. So as you can see that the conclusion of one of these is now the hypothesis of the second one. So if these two things are true, then what we can essentially do is cut out this middleman. So then we can say if go right from P then R is true. So those statements there are true. So let's look at an example of this. So look at the first one. If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has four sides. So look at the conclusion of the first statement and the hypothesis of the other. So since these are the exact same thing, saying that their figure is a rectangle, what we can do is essentially cut out the middleman. And what we can do is come up with a new conclusion. And that's going directly from if a figure is a square, then the figure has four sides. So that's the idea behind the law of syllogism. So the second one here, if a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, then it is divisible by 5. So once again, we have the same thing here. It is divisible by 10. If a whole number is divisible by 10, we're going to cut that out and go right from if a whole number ends in 0, then it is divisible by 5. Sometimes the statements are going to share the same if. If that's the case, then you can't write a new conclusion. Sometimes they're going to share the same then. If that happens, you can't write a new conclusion. The only time this happens is a conclusion of one is also the hypothesis of another. Same thing can happen if the statements were switched as well. There are a bunch of properties that you need to be familiar with as well. Now, you've been using these the entire time you've done any algebra property or problem. So just to kind of go through them, the first is the addition property. So the addition property pretty much says if we have two things that are equal to each other, we can add the same thing to both sides. The subtraction property is very similar to that. If A is equal to B, then we can subtract the same thing from both sides. That's what allows us to move numbers back and forth. The multiplication property allows us to multiply both sides with the same number. And the division property, as long as it's not the value of 0, we can divide both sides by the same number. So the things that may be new to us are the reflexive, symmetric, and transitive properties. The reflexive, think of like a mirror. It's the exact same thing on both sides. This is stating that A is equal to A. And it might seem redundant and obvious, but you'll see how it's used in the future. The symmetric properties allows us to move things on the left and right hand side of the equal sign. So if A equals B, then B equals A. The transitive property is kind of like the law of syllogism. If A is equal to B and B is equal to C, then A is equal to C. That's like saying if I'm the same age as you and you're the same age as your friend, then I have to be the same age as your friend. The next property is the substitution property. This says if A is equal to B, then we can put B any place that A is in the expression. We're used to doing substitution and putting things in for variables, but as you're going to see when we start doing some proofs with algebra problems, is that we're going to be using that quite a bit as well. The only other problem that we have is our distributive property, and since the sum and the difference is the exact same thing, we can distribute through with a variable, whether it be a plus or a minus sign. We can also do this with congruence, with the reflexive, symmetric, and transitive property. So if segment A is also congruent to itself, segment AB. Same thing with angle. Angle A is congruent to angle A. The symmetric property, same thing. We can switch things to both sides, and the transitive property as well. Okay, so the properties of congruence are very similar to the properties of equality. You'll see in a moment how we use those. The last thing I want to go over with you is proof. We're going to be doing a lot of two-column proofs in this unit, and I want to make sure we know what they are. But a proof is an argument that uses deductive reasoning, so the if and then kind of idea. A two-column proof is when we do the most, and we're going to be listing each statement on the left and the justification reason for each statement on the right. So this is how we set it up. So this is an example of a proof. At the very top, we're going to create our two columns. On the top left will be statements, and on the right is going to be reasons. The first statement is usually the given. So in this specific example here, I'm saying the measure of angle 1 is equal to the measure of angle 3. Okay, sorry about that. So in this one, the given statement was the measure of angle 1 is equal to the measure of angle 3. So that's usually the first thing we write down. The next thing is a bunch of statements here that is going to follow some kind of logical order from statement to statement. So there has to be some reasoning behind it. Usually something follows from the previous one, kind of like the two laws that we were just discussing. So this is just filled up with a couple of different reasonings. And the last thing is what we're trying to prove. So the last thing is what we want to prove. In this case here, it would be the measure of angle ABC is equal to the measure of angle DEB, and we also have to have some kind of reasoning for it. Again, we're going to do more proofs in the next couple of days. If you have any questions, write them down and bring them to class or fill them out in the survey. Please make sure you do the survey once the video ends. See you tomorrow.